in order to practice absolute configuration further, let's take now more examples. If we look at this structure and the tetrahedral carbon, we would see that this has bromine, carbon, carbon, and carbon. Obviously, bromine has the highest atomic number, so it should receive the highest priority. Between the alkyne unit, the ethyl group, and the methyl group, obviously the methyl group should receive the lowest priority actually, so priority number 4. If we write the details of this alkyne unit, so what this carbon is this carbon, it has a triple bond with that carbon, so it's like 3 single bonds. Remember that multiple bonds are viewed as single bonds. If there is a double, it's like 2 single. If there is a triple, it's like 3 single. So this carbon has a triple bond with that carbon. So CC, CC, and CC. And this carbon has a triple bond with that carbon. So if that carbon is this one, if that one is that one, then it has a bond with this. And 2 additional single bonds with carbons. And obviously, it has a hydrogen. So this is a detailed picture, if you like, of this alkyne group. Again, carbon has a triple bond with carbon, so it's like 3 single bonds. That carbon can be viewed as if it's this one, and therefore, which has also a triple bond with the other carbon, so it's like 3 single bonds, so that one, and that one, and of course it has a hydrogen anyway. The ethyl group has, this carbon has hydrogen, and obviously carbon from the methyl group. So it's like HCH versus CCC. So it's actually very clear that the alkyne unit is of a higher priority than the ethyl group. So therefore, this should receive priority number 2, and the ethyl group should receive priority number 3. So if you look at the way these are prioritized, you would notice that the lowest priority group is actually at the front. It's outside the plane, of course, but it's at the front, not at the back. It's not on the plane as if it's represented by a solid line. It's actually outside the plane as represented by this heavy wedged line, and therefore it's at the front. So what do we do now? Obviously, always, after the assignment of priorities based on atomic number, we look at the molecule so that the lowest priority group is away from us. We look at the molecule from an opposite direction to the lowest priority group. And the lowest priority group is actually towards you as a viewer, so we need to look at the back. If you like, if the group is in front of the whiteboard, okay, we need to look at the from the back, from the direction which is behind, if you like, of the whiteboard. If you do that, what do we see? Now, what we see is actually the bromine group is up, and then the alkyne unit on the left side, and of course the ethyl group on the left. So this is actually what we get. We have Br here. If you look from behind again, okay, this is the way we look. We should look at the molecule always opposite to the lowest priority group. Again, that's the I. Okay, so Br up. Okay, the ethyl group on the right side, and the alkyne unit on the left side. So what do we have? Again, let's put the priorities. So that's number 1. This is number 2, and this is number 3. And if you look at this, it's 1, 2, 3. So therefore, it's counterclockwise, and therefore it is S. It is S. So this representation is of an S absolute configuration. If you like, we can actually, since the lowest priority group is drawn at the front or outside the plane to the front, another way of doing this is to check the current rotation and then reverse it. So 1, 2, 3. That's clockwise. If you reverse, of course, you get S. But of course, that one is better, is always to view the molecule so that the lowest priority group is away from us, or we need to look at the molecule from an opposite direction to the lowest priority group. If you do that, okay, or if we look from here, we see bromine up, we see the ethyl group on the right side, and of course the alkyne unit on the left side. We end up with 3 groups, and we check rotation. It's 1, 2, 3, so therefore it's counterclockwise, and therefore it is S. If we take this one now, we have nitrogen, carbon, hydrogen, and carbon. nitrogen, carbon, hydrogen, and carbon. Nitrogen is of the highest, actually has the highest atomic number. So therefore, this has priority number 1. Clearly, hydrogen has priority number 4. So 2 and 3 are actually between the vinyl group and the methyl group. If you write the details of the methyl group, you would see that this carbon, the first point of attachment, has H and H, so 3 hydrogens obviously. So hydrogen, hydrogen, and hydrogen. If you look at the first point of attachment here, that's this carbon has a double bond with that carbon, of course. So C, C, and hydrogen, which is that one. So this carbon again has a double bond with that carbon. So it's like 2 single bonds, and hydrogen, this carbon can be viewed as if it's that one. It has a double bond with that carbon. So CC, CC, and of course 2 hydrogens. So this is a detailed picture of the vinyl group. So it's H. If you look at this atom, it has H, hydrogen, carbon, and carbon, and this one has hydrogen, hydrogen, and hydrogen. So it's actually very clear that the vinyl group is of a higher priority than the methyl group. So therefore, this should receive priority number 2, and the methyl group should receive priority number 3. The lowest priority group is outside the plane at the front. We always look at the molecule from an opposite direction to the lowest priority group. So this is the direction of sight, if you like. And if you do that, what do we see? Well, we actually see the amino group up. So that's exactly what we see, the amino group up. And on our right side, we see the vinyl group, this one here. And on the left, we see the methyl group. Again, if you look at the molecule like this, okay, we see the amino group up. We see this group on our right side, and of course the methyl group on the left. So this is up, amino group, the vinyl group on the right, the methyl group on the left. If you put priorities, again, that's of course number 1. The vinyl group is number 2, and the methyl group is number 3. And if you check rotation, you will see that it is actually clockwise rotation, and therefore this configuration is R. So this is or this structure has an R absolute configuration. So this example again represents another example where the lowest priority group is actually outside the plane, but it's outside the plane at the front. Always we look at the molecule so that the lowest priority group is away from us or from a direction that's opposite to the direction of to the orientation of the lowest priority group. Again, one way to look at this, as we did before, is to check the current rotation and reverse it. If you check the current rotation, you will see it's actually S. If you reverse it, you get R. But again, this way of viewing or directing the sight is actually more efficient. So these 2 examples represent examples where the lowest priority group is at the front. And in conclusion of all of these examples, now we mentioned the rules again. We always assign priorities based on atomic number as rule number 1. Rule number 2, then we look at the molecule so that the lowest priority group is away from us or behind. And of course, there are different ways of tetrahedral representation, so we have to exercise care in that task. If the rotation is clockwise, it's R. If the rotation is counterclockwise, it's therefore S.